Question 7 of the January 2021 CSEC Mathematics past paper. Let's see what's going on here. It says the diagram below shows a sequence of figures made up of circles with dots. Each figure has one dot at the center and 4 dots on the circumference of each circle. You can see that, right? The radius of the first circle is 1 unit. The radius of each new circle is 1 unit greater than the radius of the previous circle. Okay. Except for the first figure, a portion of each of the other figures is shaded. Well, the first figure, figure 1, is completely shaded, but for figure 2 onwards, is only a portion is shaded. What they say? Complete the rows in the table below for figure 5 and figure N. Alright. I've already copied this and placed it over on this other screen. Before I do that though, let's see something. How did they get these numbers? Let me see. Here. Number of dots. The number of dots. 1, 2, 3, 4, 5. Okay. Number of dots. 5, 6, 7, 8, 9. So you have 9 there. Then 13. You already have 9. 10, 11, 12, 13. So you keep adding 4 more dots. 14, 15, 16, 17 to get this. Okay, good. The area of the outer or largest circle. This is 1 unit. 1 unit. So pi times 1 squared, pi r squared, is just pi. So that's how they get this pi here. Let's see what else we have. The area of the shaded region here is just pi. And then the total length of the circumference of our circle. Total length of the circumference. They say 2 pi for the first one. So this is radius 1, 2 pi r, which is 2 pi times 1. Radius is 1, so it's just 2 pi. Okay. Just kind of figuring out how they get these. You probably wouldn't have time for all of this in exam, but let us look at it anyway. We know that this circumference is 2 pi. 2 pi plus the radius going out is 2 plus 2 pi by 2. 2 2 is 4. So it's 2 pi plus 4 pi gives you 6 pi. Alright. So for this, it's 6 pi for the total length. Area of the shaded region would be here. The area of the shaded region would be the inside area. You already have pi for the inside. And then the outside area minus that. The total radius would be 2. So it's pi times r squared, 2 squared, minus pi. So it's 4 pi minus pi gives you 3 pi. That's why they get this. Okay. Right? The total radius is 2. Area is pi r squared, which is pi 2 squared, which is pi by 4. 4 pi. Minus the inside radius is pi. 4 pi minus 1 pi is 3 pi. That's interesting. What about the area of the outer or the largest circle? Well, yeah, the total area. It means the inside unshaded plus the outside shaded area. The total area was 4 pi. Then you have figure 3. How did they get these? Number of dots. Alright, we saw the number of dots already. How they got the number of dots? Total area. The radius is 1, 2, 3. So radius is equal to 3. Total area is pi r squared. Pi by 3 squared, which is pi by 9. 9 pi. So we see this. Area of the shaded region will be total area 9 pi minus the inside area. The inside area would be small, similar to that of the previous circle in figure 2. 9 pi minus 4 pi. Previous circle was 4 pi. 9 pi minus 4 pi gives you 5 pi. Well, good. 5 pi. Then the total length of the circumference of all the circles, it would be 2 pi. The total length of all the circles. The inside one is 2 pi. The second one is 6 pi plus, so you have 2 pi here, then 6 pi, the second one, plus the outer one would be 2 pi r. 2 pi times radius of 3. 2 pi plus 6 pi is 8 pi plus, hold on, you have total length is 2 pi plus, you have 2 pi inside plus 6 pi plus 2 pi r. 2 pi times radius 2, 3, 6. 8 and 6 is 14. How did they get 12? How did they get 12 here? You have for figure 3. Let's look at figure 3 again. For figure 3, the total length of circumferences of all circles. You have the inside circle. It's 2 pi. 2 pi by 1, which is 2 pi. We get this. Then you have the second circle. This one is 2 pi by 2. Oh, it's 4 pi. Yeah, 4 pi. It would be 4 pi. Alright. That's what's going on here now. Plus 4 pi. So this should have been 6 pi plus 6 pi, giving you 12 pi. Alright, let's see how they get this now. Alright. So you see what's happening. How they get these values. Right? Now you have 4 more. That's making 17. Area 1, 2, 3, 4. This one, the 16 here, is pi by 4 squared, which is pi by 16. Okay, good. Area of a shaded region here would be pi r squared, 16 pi minus the inside circle, which is 9 pi, and then 16 minus 9 is 7 pi. So that's how they get the 7 pi. Good. And then the total of 20 pi. The 20 pi would be the inside 2 pi r, which is 2 pi plus radius is 2 pi 2 pi by 2 plus radius is 3, 2 pi by 3 plus radius is 4, 2 pi by 4. So what you have is 2 pi plus 2 2's 4 pi plus 2 3's 6 pi plus 2 4's 8 pi, 4 and 2, that's 6. 6 and 6, 12. 12 and 8, 20. Okay. But anyway, we were just looking at it, analyzing it. But you wouldn't really have time for all of that in exam. But let us see what could possibly be happening here. Figure 5. You know that you just add 4. So it's 17 plus 4 would give you what? 21. So that would be 21. Right? You have 25 pi. Area of the shaded region now. Figure 5. You can see a pattern here. This is 1 pi. You add 2 to 1, you get 3. You start to see the pattern. You add 2 to 3, you get 5. You add 2 to 5, you get 7. You add 2 to 7, you get 9 pi. Alright? Here, what do you do? 2, 6, 12, 20. What's the pattern here? The difference between this and this is 8. The difference between 12 and 6 is 6. The difference between 6 and 2 is 4. So it seems as if the difference between the next one and this would be 10. 4, 6, 8, 10. So if you add 10 to 20, what you would get is 30 pi. Alright? Would that really have happened, by the way? Area of the shaded region. The area, if you had one more after this, a bigger one, the area, you have 1, 2, 3, 4. This radius would be 5. Right? The radius would be 5 units. So pi 5 squared with 25 pi. So you have 25 pi. You have it here. Let me see now. If you subtract the previous area to get the area of the shaded region, you'd have to minus 16. 16 minus 9 would be, 25 minus 16 would be 9. Alright? And you have 9 pi here. That's the area of the shaded region. This is showing you the difference between the biggest and then the next biggest circle. And then the total length of circumference of all the circles. When you add them all up, you keep adding, you have to keep adding these up. Alright? You have to keep adding up the circumference of each circle. But the thing now is this. Let's see what this one is saying. Determine the value. Oh, we already did this and this. Oh, for n. Determine the value n. Okay, we're supposed to find n. We're supposed to find n. See if we can use a pattern to find it. Figure 1 is 1 pi. Figure 2 is 1 less pi. Let's see now. How do we get this again? Let's revisit the calculation. Alright? Now, the total area of a circle. This was 5 pi by 5 squared, pi r squared. This was pi by 4 squared. It was pi by 3 squared, and so on. It's 25 pi, pi r squared. For figure 5, pi by 5 squared. Figure 4, pi by 4 squared. figure 3 pi by 3 squared, and so on. So for figure n, it would be pi by n squared. Let's call it n squared pi. So it's n squared pi. You have this. Now, as for this one, number of dots, you have 1. Now, this figure 1, you have 1 dot plus 4 by 1. You can see it, 1 circle. Figure 2, it's 1 dot in the middle plus 2 more circles around it, 4 by 2. 2 4 is 8 plus 1, 9. Alright, will give you the 9. This one will give you the 5. Figure 3, it's 1 dot. You have the 1 dot here. Plus, how many 4s do you have? 3 more. So it's 4 by 3. 4 more dots. 4 dots for each circle. And 3 of them. 4 3 is 12 and 1, 13. So that's how you get this 13 here. Figure 4. There is 1 dot in the middle. Is this plus for each circle you have 4 dots. How many more circles you have? 1, 2, 3, 4. So it's 1 plus 4 by 4. 4 4 is 16 and 1 17. That's how you get this 17 here. Alright? So what happened in this case? This would be 1 dot plus 4 dots each time n number of circles. So it's 1 plus 4n, or you could say 4n plus 1. So that's how you get this. Alright? You see that? Okay. Now, let's figure out the area of the shaded circle. Let's erase some parts of what we did already. We just erase some of this work here. You can always go back and do a screenshot of the work. Let me see something here. I could erase. This was 9 pi. 9 pi. Alright. This was 21. So let me just write the 21 here. 21. Okay. And this, let's not have too many things on the board. No. Alright. This was 30 pi. So 30 pi. Let me write the 30 above this line here. 30 pi. Good. Now the thing is this. We want to figure out this one. For n. Now the area of the shaded region. Now the thing is this. The total area. The area of the shaded region is the total area minus the previous area. I just say AT minus AP. Area total minus area previous. But anyway, we have the area of a shaded region here. For figure 1, it was just pi. Right? Pi r squared, pi by 1 squared. For figure 2, the area, this area of a shaded region, in figure 2, we want this. Is the area, the total area, the outer circle, 4 pi minus pi, not minus 3 pi. It was minus pi. Remember, it's 4 pi minus the previous one here, giving you 3 pi. But the previous area was pi by 1 squared. Alright? Now, as for figure 2, you had pi by 1 square for the inside. The total is 2. How you get the 4 pi is 2 squared pi. So for figure 2 is 2 squared pi minus 1 squared pi. Let's write it that way. Minus 1 squared pi for figure 2. For figure 1, it was 1 squared pi. Figure 2 is 2 squared pi minus 1 squared pi. What about figure 3? It would have been 9 pi, which is 3 squared pi minus the previous, which was 2 squared. Let me rewrite that. It was 2 squared pi minus 1 squared pi. See that? For figure 4, what would it have been? It was 4 squared pi minus all of this. 3 squared pi minus 2 squared pi minus 1 squared pi. So it's 16. Oh, no. When we subtracted this, we already got it. I didn't need to do all of this minusing, right? 3 squared pi, 9 pi minus 4 pi. This part here, I didn't need to do all of this. My mistake here. When we find this outer minus the inner, this inner already included everything here, so was my error in putting all of that minusing business together. So this wouldn't be needed, this would be needed. So what you have, 2 squared pi minus 1 squared pi. That gives you 4 pi minus 1 pi, which is 3 pi. Good. This one would have been 9 pi. 9 pi minus 4 pi to give you the 5 pi. This one would have been what? Would have been 16 pi. 16 pi minus 9 pi to give you the 7 pi. Alright? You see that? And then for this one, what you would have had for figure 5 is 5 squared pi minus 4 squared pi. That's 25 pi minus 16 pi to give you the 9 pi. You see that? So, what do you think n would be here? Alright, look at the pattern. Figure 1, 1 squared pi minus 0 squared pi. Figure 2, 2 squared pi minus 1 squared pi. Figure 3, 3 squared pi minus 2 squared pi. Figure 4, 4 squared pi minus 3 squared pi. Figure 5, 5 squared pi minus 4 squared pi. So figure n is, it seems to be n squared pi minus what? 1 less. N minus 1 squared pi. You see that? Alright? So here, what you have, if you simplify this now, you get n squared pi minus n minus 1 squared pi. Should I bother simplifying it? Alright, let's write it as it is now. if you put pi outside a bracket, let's not try to expand the bracket just yet. I'm not sure you're going to really need to do it. It's pi times n squared minus n minus 1 squared. It's kind of too jumbled up here. Let me write it with smaller. It's pi, open bracket. Or we could just write it as it is. Let's not put any bracket. Let's just write it as it is. N squared pi minus n minus 1 squared pi. Alright, we have it as that for now. The circumference of all circles now. Let's figure out the circumference of all the circles. Here, let me just erase part of this thing here. Let's erase this here. And then we see what the circumference of all the circles would be. Alright. So, 2 pi. How did you get this 2 pi here? For figure 1, it would be 2 pi times 1. For figure 2, the unit, the circle was 2 units long. It's 2 pi times 2 minus 2 pi times 1. Remember, figure 1, it was 1 unit long. Remember it? The radius was 1 unit. So, it's 2 pi r, 2 pi by 1. Figure 2, it's 2 units. So, it's 2 pi r, 2 pi by 2, minus the inside circle. The inside circle was 2 pi by 1. So, 2 pi plus is plus. Why am I putting minus? Is it total? Plus. So, it's 2 2's 4 plus 2, which is 6 pi. For this one, 3 units. The radius was 3 units, so it's 3 pi r. No, oh my. It's 2 pi r. 2 pi 3. Alright? Plus the previous now would be 2 pi 2 plus 2 pi 1. So you have 6 plus 2 2's 4, 6 and 4, 10 plus 2 more, which is 12. This was for figure 4, 2 pi 4 plus 2 pi 3 plus 2 pi 1, 2 plus 2 pi 1. So it would be 2 2's 4, 2 4's 8 and 4, 8 and 12. And then of course this would have been 5 pi, no, 2 pi 5 plus and these. But here now, what you're going to do is find out what pattern could include n in this. So let's see. Here you have 2 pi times the number. It's 2 pi times n plus something else. So something else. Alright? 2 pi times 5 plus the previous, which is 2 pi 4 and so on. So far, you can see, let me just put it over here. This seems to be developing into 2 pi n plus something. Right? Plus what? Let's see if we can come up with some other pattern. Here. Right, so here now. Could you factor out the 2 pi and see if that would help? If you do that, for example, with this one here, you'd have 2 pi, and you have 4 plus 3 plus 2 plus 1. But then, what would happen? With 5, you'd have 5 plus all of this. So how would that help you then? Let's see if we can figure out some way to link the figure number to these numbers that are at pi. Alright? Can we do that? I'm thinking now. Suppose you say 1 squared. 1 squared is 1 plus 1. You get 2. Suppose you say here 2 squared plus 2 itself. 2 2 is 4, 4 and 2 is 6. You get 6. Suppose you say for this is figure 3. 3 squared plus 3. 3 3 is 9 and 10 11 12. Oh, so this is 12. Interesting. Let us see if it would work for this. Figure 4. 4 squared plus 4. 4 4 16 plus 4 20. Interesting. Suppose here for figure 5, you say 5 squared plus 5. 5 squared is 25. 25 plus 5 is 30. Well, that seems to be working for the total length of the circumferences of the circle. Alright. So, what we'll do is work with that pattern. So, let's just... Oh, this was what? 30 pi. Alright, let's put it back there as 30 pi. And just work with that which we have so far. It was 30 pi. And I was saying, this was 1 squared plus 1, which is 2. And you have pi beside it. This was, for figure 2, 2 squared plus 2, which would turn out to be 6. And you have 6 pi. You put the pi there. Alright. 12 pi. You got it from figure 3. 3 squared plus 3. 9 and 3, 12. 20 pi. It was 4 squared plus 4. And then 4 squared is 16 plus 4 is 20. And then you have pi. This was figure 5. This is 5 squared plus 5, which is 30. If you follow that pattern, then for n, it would be n squared plus n. That seems to be the case. Alright? So you have more than one ways to try and figure out what the pattern could be in this type of question. Alright, but anyway, let us see what is happening here. Here, they say determine the value n when the number of dots in figure n is 541. Alright? So determine the value of n when the number of dots in n is 541. Let's try that. So 541 is the figure that we're given. Alright? So 541. Determine the value of n when the number of dots. So that is which part of the question? B, part B. 541. So number of dots 541. So in this case, you have 4n plus 1 is equal to 541. 4n is equal to 541 minus 1, which is 540. n would be 540 divided by 4, which is 5 into 5. 4 into 5 goes 1 time, or 5 into 14. 4 into 14 goes 3 times, leaving 2. 4 into 25. 135. Right? So, it would be 135. So here now, what else is happening? Write down in terms of P and pi the area of the largest circle in figure 3P. Figure 3P. Interesting. The area of the largest circle. Area of the largest circle. N squared pi we got. So for figure 3P, this would have been what part C? Part C of the question. The area of the largest circle in figure 3P. Area of the largest circle, n squared pi. So in figure n is n squared pi, so in figure 3P is 3P squared pi, which is 9 p squared pi. Well, that's what I have here. And that seems to be the end of question 7. We'll look at question 8 in our next video.